when you talk about learning models, these are more like neural networks. So what's happening now is when we are transitioning from machine learning to deep learning, we are trying to mimic the human brain over here. So if you look into the human brain, we have a lot of neurons, right? And these neurons are connected, and we call it as neural networks. And the data keeps on passing through these different layers. So here also we are trying to mimic how our human brain functions, and that is why you will see that there is some data which is fed to the input layer over here, and then this data has been passed to multiple of these neural networks. So these blue layers are the hidden networks internally into a network, and then there is an output layer which gives out the output for that. And these circles that you see over here, these are just some kind of mathematical operators, which we call as activations. So as and when the data traverse from one layer to another layer, there is some kind of a mathematical operation that happens onto after each traversal, and accordingly the data is passed towards the output layer, and what we get is a final numeric an interpretation of what's happening internally in the hidden layer, and that is what we then try to interpret something around it. While we train a network, what's happening is these activations that talked about, basically the mathematical operation, what mathematical operations will happen, what magnitude of that will happen, and all that thing is actually being decided and set. So after every after every training cycle, these activations are actually updated to make it even more and more better, and that's how it works. So that is how, in a very high level nutshell, we do when we are training a neural network. Any queries with this? Okay, sure. So what we are trying to do, because I said that all the data that we are sending is there is some kind of a mathematical operation. And why we are choosing mathematical operations over here is because any data that you have that can be somehow represented as a numeric value. So if you see at an images, as you know, can be considered as a matrix, as a RGB matrix, which has levels of intensity. So you might have seen this in the previous two sessions also, that how images can be represented as numeric matrix, right? Again, signals are also some kind of magnitudes in one dimensional. Images are three dimensional when we talk about RGB, whereas e- uh, whereas signals are one dimensional magnitude values. So you can see that it can be anywhere represented as some kind of number. Similarly, text also, if you have, that can also be represented as some kind of a numeric array. So that is how the ASCII values and other things come into the picture, right? So every alphabet is represented as its corresponding ASCII value. And there are other notations and representations of text as well. But in a nutshell, what I want to focus over here is any signal, any data that you're trying to work around can be somehow represented as a numeric value, and that's how these numeric values are then passed to the neural networks. And then we talk about mathematical manipulations and mathematical computations happening over the deep network throughout different layers of it. Any queries with this point? Just a second, I'm getting a call. Just a minute. Yeah, sorry about that. So yeah, as we was talking about, all signals can be converted to some kind of a numeric data, right? So what we'll try to do now is uh, we'll see how to build networks from scratch and how or use pre-trained network. So the next two exercises that we do will be looking into how to create something from scratch. But how to do that is what we'll see, look into first. So I was also talking about scenarios where you need to take a model from one platform to another, or bring a model from another platform to your
Hello,
platform.
sir. You are mute, unable to listen to your talks.
Is it for everyone?
No, sir, you are audible properly. Ma'am, please check with your system.
Okay. Uh, Thanks for confirming. Maybe just check with your speakers or something. Uh, yeah. So as I was saying, there might be scenarios where we need to take our models from one platform to another, and so it for that matter to a platform like TensorFlow or PyTorch or any other platforms also. So MATLAB is one platform where these things can be done pretty much very easily. So we can bring a model from TensorFlow directly to MATLAB, or from MATLAB to TensorFlow, or through to PyTorch, or vice versa. And if you're looking into some other platforms, then there is something called as ONNX framework. So this will help. Through this particular framework, you can take it to some other platforms also, and that's where we talk about interoperability of the models and the tools. So assume that you have a pre-trained network that you want to use, and your algorithm is some part of your pre-processing or post-processing is already there in MATLAB. You can just take that model, import it to MATLAB, and then start using that model, or even use transfer learning on that. So it is pretty much possible. So we'll see that in next part of the sessions, and it will be covered in the next 2 days also by my colleagues, and they will actually talk you on how that can be done. So we have this exercise. This is the first one that we'll try to do. What we'll do is we have a pre-trained network. We'll try to import it and then use some images to classify that. And then see how how the network is working on that or not. Okay, any queries with understanding what we are trying to do? So first and foremost, we'll load a network, and we have some images that will run through those networks, and we'll try to classify those images. So that's the whole motive of this, just to understand on how things can be done. Any queries with the problem statement here? Okay. I hope the download of you might have able to download it by now, or the files that I have already shared with you. Okay, if it is a zip file, please extract it and save it somewhere on your systems. Maybe we'll wait for a couple of minutes for everyone to be on the same page. Just extract it and save it somewhere. And meanwhile, also open MATLAB onto your systems. Also, please, people who are using MATLAB, can you just mention whether you're using the online versions or the desktop versions? And if you're using the desktop versions, you can write in desktop and the version of it, like whether it is 24A, 23B, or whatever that you're using. Okay, great. Uh, just one person using MATLAB as of now. Can someone or others also mention which versions they are using, whether it is MATLAB Online, MATLAB Desktop, and which version? Online will definitely be on the latest one. I just want to understand like which versions of MATLAB you're using if you're using desktop ones. Okay, Rakesh sir, if you are using 18B, many of the files may not work because there is a transition when we are talking about the latest versions of deep network designers and deep network, basically the entire AI workflows that we are saying. So some of the files may not work for you, but for now you can just observe and have a look at into that because 18B is very like very old version which is now outdated. So there are just three people who have access to MATLAB is what I understand at this point. Anyone else who is working or having access to MATLAB? Okay, online. Even if you're using the online version, please put it in the chat as online. So at least I have understanding of how many people are going to work on the hands-on. Okay, so with that, I open MATLAB window. So I hope my screen is up and you're able to see my MATLAB window. So this is the newest version of MATLAB. This is 25A. So there are some differences that you might see in the look and feel. This is more like if you have used MATLAB online, it looks more like that. And the latest additional feature that we have got is this particular bit. So you can see something called as a Copilot chat over here. So it's more like creating codes, and you can actually use it as a Copilot when you are coding or working on MATLAB then and there itself. Uh, so this was a feature that we were working on quite some time, and now it has been rolled out in 25 ways. So please go and check it out if you haven't as of now. Uh, so what I would also request everyone is once you open MATLAB, click on this particular browse for folder option. So you can see that this particular button is browse for folder. So yeah, also one more thing. So if anyone is using MATLAB online, you will have to upload the files that you have downloaded to your MATLAB drive. Because in MATLAB Online, the only option to have access to the files is through MATLAB Drive. So once you download those files, just copy and just drag and drop it to your MATLAB Drive. So it, it might be seeing over here as slash MATLAB Drive instead of this entire address that I have. So just drag and drop the files that you have downloaded onto your MATLAB Drive, and it will automatically get uploaded there. Hope that's clear for people who are using online versions of MATLAB. And please upload the unzipped version of files and not the zip version because that MATLAB won't be able to access it. Please let me know if you have any queries with that or is it clear on how you can go ahead and upload it, specifically for people using online versions. That's perfectly fine. We can talk about enabling or not. So Copilot is not, we are not going to use it right now for this particular session. So that's perfectly fine. It might be a scenario that your IT admin or the college might have also disabled it. So we can talk on that at the later point as well. For this particular session, we are anyway not going to use Copilot. But what I need to understand is whether you have access to these files. First and foremost, whether you have downloaded it, whether you have unzipped it, Thirdly, if you are using MATLAB online, whether you have uploaded this file to your MATLAB drive, and if you are using MATLAB desktop, have you changed the directory and this clicked on this particular button and selected the place where these folders are. So once we are done with these steps, please let me know. You just navigate to the folder where you are, where you have downloaded and extracted it, and then select that particular folder so that you have all the files over here. Once you have completed these steps, maybe you can just put completed in the chat. Narkis sir, it should not take a lot of time to extract. You don't need to have a down upload button, ma'am. So what you need to do is just, for example, if I'm using MATLAB online, just have the browser here somewhere. And for example, if these are the files, just copy and then drag it from here to here, something like that. It will get directly uploaded. If you're unable to do it, it would be great if you can let me know what issue or challenge you are facing so that I can help you accordingly. Ankit, are you there in the call by any chance?
Yes, yes, Nikhil, I'm here.
Yeah, Ankit, can you just check with the people who are not able to understand? You can just chat with them privately and get the issue resolved.
Okay, okay.
Thanks, Ankit. Yeah, so what I'll do is, so this is the file. So if you have either you'll be able to see exercise files like this, or you will be able to see all the files like this. In any case, just select all. Ankit, can you mute yourself, please? Thanks, Ankit. Yeah, so what I was saying is once you have these files seen over here, you may have to select all, right click and add to path. For now, I have already added to the path, so it is showing me remove from path. For you, it might be showing add to path. So add to path and selected folders and subfolders is what you will select. So basically, you're telling MATLAB where my files are and where to access the files that I might be giving locations or names to. Yeah, it should work for 23A. Sorry, it will work from 23B, not 23A, because there was some modifications at 23B. So from 23B, if you have any versions, it will work. But anyways, you can just observe Rakesh sir for now, and maybe later on you can work on the files for that particular versions as well. So I'm skipping the first part of getting started exercise. You can try it later on also. And Ankit might have also covered. It's just trying to use like loading a signal, loading a network and then trying to run that and check whether it's working or not. So what I want you to do is double click on this pre-trained network, pre-trained models. So it's the folder number 2, pre-trained models. Double click on that. And then there are two files, work underscore pretrained models. So work underscore is a file where you can actually, there are some parts of the course which are missing and you will be working on them. Solution is the final answer with all the code being written over there. To just save some time, I am opening the solution pre-trained models, but you open the work underscore pre-trained models and then try to work on that. Okay, so I'll just maximize this. So what we are trying to do over here is, as I said, we'll be loading a pre-trained network. A pre-trained network is a network which is already trained for some data set, and we can directly start using it for any of the real data that we have or any data that we want to test it out on. So here, for that matter, what we are doing is this particular line is helping us to load a network specifically. So image pre-trained network is an inbuilt function, and then we are specifying the name of the network inside that. And then once we specify that, it's a drop-down menu. Okay, so you can select. For now, I would suggest you to use AlexNet only, but later on, you can try out different networks also. It might also happen that if you're trying out any of the networks, it may show that the network is not downloaded specifically for the desktop versions. So we'll have to go and like go into the add-ons tab, sorry, over here, and then get into add-ons, and then add that particular network. So depending on the requirement, you can add specific pre-trained networks to your MATLAB. Okay, so I'm selecting AlexNet for simplicity. I will just run through this particular section. So it is actually loading that particular network. Uh, is my screen visible? If someone can confirm that.
Yes, sir, it is visible.
Yeah. So you can see that once I run through this particular section, there are some variables that are created in the workspace. That is this net and class name. So we created these variables here, and what this function did is it loaded this particular network, and that network is here as an object called net. That is, you can see the value, it is DL network, and the class names are being saved in the variable called class names. So basically, if I open this class name variable, it is of the size 1000 cross 1. So it will have 1000 different classes. So uh, AlexNet is basically trained for these 1000 classes. So these are different classes, and the images of these classes have been used to train this. So anything among these particular 1000 classes, it is able to classify. Anything outside, if it is given, it may just give some garbage value. So that is what AlexNet is going to do. What we plan to do next is I just run through this particular section. This section will just let us know what are the different layers into this particular network. So there are about 24 layers that we can see. And again, I'm not getting into each layer does and all, but these are some internal layers. So there is an input layer, image input layer, and then there is a softmax and the fully connected layer at the very end, which is letting us to give the data as output. And then there are a lot of internal mathematical manipulations that are happening. And these are the hidden layers that we are talking about when we discussed about about deep learning on my slides. So this is just to analyze what the network is about. Okay. So the next thing is what we are trying to do is we'll take one of the image and then we'll try to see what this image is, and then we'll try to classify that. So what I'm doing over here is I'm giving the location of the image which I want to classify. So this is in this 02 underscore image. So you can see that there is a folder over here, and then internally there are multiple images here. Okay, so these images I want to access. So I'm just using for the first file, first image, and this IM show is just displaying that image, nothing else that we are doing at this point of time to access the network or anything. I'm just reading an image and displaying it. That's all. The next part of what I'm doing is I'm checking what my input size of the layer is. So what I'm doing is here when we use the command net.layers, it just displayed the layers. Here what I'm doing is I'm accessing net.layers bracket one. So what is the first layer? And then dot input size. So what is the input size of my first layer? So that is the input layer. So I just want to understand and know what is my input size, because the images that I have, they might not be of the same size. And what always, whenever we use any network, we'll have to pass the data according to the acceptable size of the input layers. So that is the photo. Otherwise, it will throw some errors because it can only process data of that particular size. So here we get to know that my input size of that particular layer of of AlexNet is specifically 227 cross 227 cross 3. 3 being because it's a colored image, and the x and y coordinates or x and y sizes of that will be 227 cross 227. So now first and foremost thing is I need to resize my image that I want to pass through this. So this is where I'm doing the same thing. So I'm using the resize inbuilt function. I'm giving IM as my input. IM is coming from here. So that is what I saved it into that image. And then I'm giving it is that input size. So I'm giving it as same input size and 1 to 2. So it should be of the size 227 cross 227. So this variable I'm passing it here. Okay. And then once that I have, I'm then rewriting IM with the resized IM here. So now the size will be 227 cross 227. And then I'm passing that input image to uh, to the layer. And now my input network is net. So net came from here. AlexNet is what it was. So this is the net. We saved it into that, and that is the DL network type. Predict is again an inbuilt function which is helping us to predict. We are using the network net, and I am giving this as what I want to predict. And then it is just giving me label of scores and class names and everything. So I'll just run through this part. We'll just see what it is able to. So this was the image. So that this IM show over here. So this was the image which was predicted as seashore, and which is the correct prediction, right? There's no issues with this prediction. This is the seashore, and this is what we would also say to an image like this. Okay. Any queries with till this point of time? We just selected one image, passed it through the network, and tried to predict it. That's all. Any queries? Are you able to understand what we are trying to do? Any issues with understanding any particular line of code? I know syntaxes might be new to you, but at least you're able to understand the crux of it. Syntaxes can be learned and understood anytime. But at least the process and the algorithm is what I want to see whether you are able to understand or not. I see a couple of yeses. Uh, Good to know that, but what about others? Like we have a good number of attendees here. How does an so Ujjwal sir is asking how does the network predict it's a seashore? Good question, sir. So as I said, when we are talking about network over here, so this is an AlexNet network. Okay. Uh, so AlexNet is a pre-trained network for use for images. So even if you do a normal Google search of what AlexNet is, you'll be able to understand what it does. So assume that it is a network which is pre-trained for some set of images. Okay. And then you are feeding in some image. So depending on the the data it is trained for, so it has some information around it, right? Or on the images. It understands images, and with that understanding, it is able to give some kind of an output. It is the network's interference of the data that you are feeding in. Now, AlexNet, when I said about the class names, so AlexNet is already trained for these thousand different classes. So the goldfish, shark, tiger shark, hammerhead, and so on. So it different things is what it is trained for, and these are thousand different classes. So it knows some information around it. It has info around it, and depending on this particular information, it is able to select. And seashore is also one of them, one of the class which is there in this thousand, and that is how it is trying to uh, predict it. I hope that is clear. Yeah. So once that is done, what we are trying to do is, so again, quickly recapping what we did, uh, we took a network and we just tried to, we took a network and we just tried to load it. It is a pre-trained network, so we don't need to train that or do something around the training aspect of it. We are just using it to classify some image that we fed into it. So we just fed one image to it, and it is giving some output that it is a seashore. That's all. Now what will we do is we'll try to run through multiple images. So we have some images, and this is very important when we are talking about biomedical applications also. When we talk about biomedical applications, we won't be having just one image to work on or classify. We'll have a series of images. Might be blood smears, or it might be some kind of CT scan data, or it might be some signal data that we have, and it might be of numerous files that we have, and then we want to classify all these files at once. So it will be very difficult to select each image one by one and then try to classify it and then record the observations and so on. So here what we are trying to do is we have multiple images. So if you see in this particular folder, if I just drop it down, we see that there are about 12 images. So I want a process where I can just write something and all these 12 images are classified at once. Now again, just for this particular demo, I'm using just 12 images so that it's quickly possible to show you. But it can be thousands of images also, which happens in real life. So to do that, what we do is there is something called as image data store. So it is basic, as the name suggests, it is a storage of data, of image data basically. Lots and lots of images can be stored at once, and we can then access it easily. Again, to understand it in much more detail, I would suggest you to just read more about image data store. And in MATLAB, if any of the function that you have, inbuilt function is new to you or you don't know what it does, you can just click on it, right click on it basically, and click on help on image data store, and it will open up a separate window for the documentation of that. You can see that it is showing you the entire documentation. It shows what it does, syntaxes of it, what these particular parameters mean, and so on. And then if you want to look into examples also, you can click on the examples and look into it so that it will make you understand. You can open it in the browser also for better understanding and go through the examples too. Okay. So here what we are doing is we are giving it the image path. So wherever my images are stored, so my folder name is 02 dash images, which is over here. So I'm giving it as a path, and then that path, the entire all the folders or all the images inside that, I want to create it as an image data store. So this is an inbuilt function, and IMDS is the data store that I'm creating. So I'll just run through this file, run through this part, and you can see that there will be an IMDS variable that is created here. So this is an object IMDS that is created, and you can see that it is of the value image data store. Okay, so it has all the files that I just gave the access to. Now, again, what I'm doing here is because now there are multiple images that I want to run through the entire network. I'm using the same function here, predict net, and previously it was just one image. Now what I'm doing is I am using a loop. So this is the while loop. So I'm using while IMDS has some data. So it is like till the date there is some data in that particular image data store, this loop should be running, and then it should keep on printing and giving me the output. That's what I'm trying to do over here. Okay, so I'll just run through this part. So it's a loop that I'm trying. It's the same thing that we did previously. Here, because there are multiple images, I'm just using a while loop and just repeating the steps one again, one after the other, till all the data. So I have 12 files. So till my 12 files are over, and I run through all the 12 files, till that point, this loop should be running. So now you see that I'll just maximize or open this as a figure maybe so that you are able to see uh, you're able to see it in a better way. Are you able to run through this at your end also? Any issues that you're facing, Professor Narkade? Okay, that will take some time if you haven't installed the network toolbox or anything. For now, maybe you can just observe. You will have access to the files anyway, so you can work on that later on too. So you can see here, there are different images. So these were some of the images. And this is what the images and the corresponding predictions are. So this was the seashore, we saw it previously also. This is breakwater, hot dog, lakeside, bakery, and something. So there, as I said, AlexNet is trained for 1,000 classes, right? And depending on that information, it is trying to classify. Now I want to understand from you. Just have a look at this particular predictions of these images. Is this network doing a fair job? That's a question to all of you. Looking at this, the images and the corresponding predictions, what do you think about the network? Is it able to do a fair job? Is it able to predict it correctly? Predict the images correctly? Okay. Uh, let's look at some of them. Yeah. Professor Narkare mentioned most of them. Yes, that is correct. Again, just a question to you. If you look into this particular image, okay, this is getting predicted as a bucket. Firstly, is it correct or is it not correct? Okay, if again giving, like rephrasing the question, if this image was shown to a human being, what would be our prediction on that? What we would say? It might be a baby or a kid or something like that, right? Yeah, Professor Narkade, kid taking bath in a bucket won't be giving like that is our inference. But if you want to just classify it into one class, generally our human brain would say that it is a baby or a kid or a human, right? Not a bucket. So that's how we perceive things. The first thing we would see is a kid. Now, the network here is not doing a wrong thing. It is predicting it correctly, but it's just about inference and understanding what or prioritizing on what we see over there. Similarly, for this also, it's not a paddle, but it's a like a fire extinguisher or something like that, right? Again, this is not a bakery altogether. These are just cupcakes. But yeah, it is inferencing it like a cupcake or sorry, a bakery or something like that. So again, this is more around the accuracy and any network is as good as the data it is trained on, and there will be some accuracy issues related to it. Any network cannot be 100% accurate and predict everything. And that is how different networks will behave differently to images like this. So, as a homework exercise, maybe what you can do is there are other networks also here in the drop down, and I would want you to try different networks over here and then see how the response of the uh, predictions, or how the predictions are different from each other. So that's the homework for you. Okay. So with that, I hope you are able to understand this particular exercise. Any queries with this? Anything that you want to know? Anything that you pay? Anything that you didn't understand? Anyone like want to just mention whether you understood or not on the chat? Okay, just one person is able to understand. Others facing any queries or some challenges around understanding? I know many people may not be able to access it due to something, some file download issue or MATLAB particular desktop, so particular toolbox not being installed, and that is fine for now unless you understand it. You can always go back and work on the files because you'll have access to the files anyway. Okay. So what I'll do is I'll go back to the slides that I was talking about. So what we saw over here is I'll quickly summarize on what we did right now. We just took a pre-trained network. Now that pre-trained network can be anything. For this matter, we just for this exercise we just took AlexNet, and using AlexNet there was a set of images that we passed through that particular network, and we try to predict what images those were. That was the exercise in a nutshell. Next, what we are trying to do is the second stage. So that was we looked into the entire workflow for deep network design, deep learning network creation, right? We we so the next part we'll see is how to look into the AI modeling part here. So in the previous one, we just used the trained network and we directly jumped onto this part over here and then try to test it directly because it was already trained. But now there might be scenarios where a pre-trained network may not be directly useful, or you will have to, there might be application that where you will have to create some network from scratch. So that is what we'll have a look into right now. But before we get into creating a network, there are some basic understanding that we need to do. So here, what we are talking is, again, there can be different deep network architectures, but what we are talking over here is our CNNs, just to start off with. So CNNs are convolutional neural network, and as the name suggests, the majority of the mathematical operation that happens over here is convolution and and that's the major thing that is happening, and that's why it is being named after that. Okay, and majorly these architectures have a convolutional layer, a ReLU layer, and a max pooling layer, and these layers keep on coming up again and again throughout the network. We'll look into what these layers do, but majorly these are the layers that are used in CNNs. Okay, just for now, just understand that these are the layers. You may not understand each layer at this point. I'll go through each of the layers, but for now, if you look at an architecture of CNN, these layers might be there and these might be recursively coming again and again. Okay, so basically what convolutional layer does is they look for patterns in an image, because we are talking about images, right? And there in an image there might be different patterns that are created. So these layers basically look for patterns in that image, and then accordingly some output is given and we infer that a particular pattern is there. So assume in the previous exercise also there was a seashore or there was a baby or a bucket or something like that. There is a specific pattern for each of these, right? There is a pattern for a seashore, there is a pattern for a bucket. So these patterns are the information that it looks for, and accordingly it will then classify it into. Now assume that for an image like this, now this is a binary image for simplicity. Uh, in this particular image, what are the patterns, major patterns that we can see? It is this particular pattern, which is here and here. It might be this pattern, which is here and here. It might be this particular pattern, which is predominantly here. Then this pattern, which is here, and so on. So, and this particular pattern here and here. So depending on the locations of this pattern, if I'm having this checks for these particular patterns over the entire image here, and if I infer on the locations where these patterns are located, I can infer that the entire image has a digit like 0. Okay, now for every digit, it might be something else also. And that is how these patterns are looked into, and that is how we infer something out of it. Okay, now for an image like this, uh, assume that this is the pattern that I'm checking through the image, and I find only this image over there. So this can, I eventually I will say that a figure like 1 or an alphabet like I is present in this particular image. So that's how it works. Okay. So what I want to also run through this is for this particular image, if I just look into, so this particular filter, I'm just running through the entire image, and that is the part where I will have some kind of activation. So basically, if you look into the convolutional algorithms that we are just running through the filters around an image, and then depending on the output that we get for a particular location, we infer whether it is whether a particular pattern is present or not. So that's how it works. So that is what convolutional layer does. What ReLU is a rectified linear units layer. What ReLU layer does is it will just convert all the negative images, negative numbers to 0. Sorry. So because negative numbers in images are more around the brightness values here. So negative numbers don't signify anything. So we just convert negative numbers to 0. That's all. What max pooling does is there are scenarios where we want to shrink the image to reduce the size of it, but we want to again preserve some important information. So that is where max pooling comes into. It is like a downsampling operation. So here, if for example, if this is an image, if we want to convert it to a 2 by 2 filter with a stride length of 2, it will be somewhat like this. So from this four elements, the maximum is taken here. From these four, the maximum is taken here, and so on. So now this is my size, or this is my image that I'll be working on. Definitely, there is a loss of information, but again, we want to reduce the size of it with some losses, where some loss is fine, but to preserve majority of the data, something like this can be done. And then at the very end, we use classification. Sorry, at the very end, we use fully connected layer and softmax layer for classification problems. And if it is a regression problem, then again, one fully connected layer will be there. But here we are just focusing on classification problems. So at the end, there will be a fully connected layer which looks into the high level features and corresponds to a specific category. And it also calculates the probability or the scores of each category. Uh, sorry, this calculates the scores, and softmax layer then converts the scores into probability. Okay. And the next question you might arise is when do I know which layers to use? So because there are a lot of layers, right? So again, for feature extraction with the existing research and experience, it can be said that majorly the convolutional layers can be used. And when you need activation functions, it can be ReLU layers or TANH layers and something like that. And when you have sequence data like signal, text, or numeric, then LSTMs, bi-LSTMs, and other things can be used. Now again, this can be overwhelming at this point of time, and you can have a reading of this particular page later on as well. So I'll be sharing these slides with you. All it has been documented and you can go over, and actually gives you an understanding of what are the applications where which layers and things like that can be used. Okay. So to train a network, we need three components. One is we should be ready with data. Second is the architecture. That is what we are trying to come up with. And then once we have the architecture ready, we'll also talk about what should be our training options. So it can be solver type, learning rate, batch size, what are the epochs and all those things. So we'll talk about that in a bit. But these are the major components that we need for training. So epochs are basically the number of times the entire training data set passes through the learning algorithm. So there might be scenarios where the data set is being is passed through the network again and again with minor uh, creating some chaotic behavior so that the network becomes more and more robust. So basically, it allows the model to learn patterns and generalize from the data. And after every epoch, the model updates its internal mathematical calculation based on the data that it is fed with. Again, learning rate is a floating point number. It is a decimal kind of a number that determines how quickly a model converges to an optimal solution. Again, I'm not getting into the very much details of how and what exactly it is, but on a very high level, it is how quickly the model will converge. Uh, and again, it is important because it affects the entire speed and quality of the training process. And a good learning rate can improve neural networks performance with up to 100% also. Again, you will have to try for different values of epochs, learning rate, and other training options, and then see what is optimal for your application, your specific application. Okay, so what we'll do now is we'll try to train a CNN from scratch. Okay, so what we do is we'll open an app which is called as Deep Network Designer, and we'll try to create a network over there from scratch and then try to see how this can be done. Okay. Any queries with the problem statement in itself? So basically, there are some handwritten data of different digits that we have. And what I want is once as a final output, what I want is if I feed some handwritten digit to the network, it should be able to predict what digit it is. So for that, for example, for something like this, if something like this is written and fed to the network, it should give me as an output that it is 7. And this should happen for all the data sets that I have. Okay, able to understand the problem statement here? Okay. So let's go back to MATLAB. Go one step back in the folders. Uh, Now what we'll do is we'll go in the third folder. So the name of the folder is 3-training CNN from scratch. You can double click on this particular folder. If you don't have access to MATLAB or facing some issues with it, just it would be great just to observe for now. And then, as I said, you have the access to the files anyway, and you can work around that later on too. So I'm opening the solution underscore CNN from scratch directly. Just maximizing this. Again, I have explained you what the problem statement is, and this is just explaining the same thing. So the first and foremost thing what we are doing is to load this particular data. What I have done is, if you don't have data in the folder, this is the first line of data that you will do. You will have to run. I have already added a data set to the same folder, so you can skip that and directly start from here. Uh, so what we are doing here is we saw what image data store does. So we are creating a data store. I'm giving the location and the folder name, and then IMDS is the data store that I'm creating. And I'm just want to have what are the class names. So I'm just having it saved in the class name variable. So I'll just run through this, and accordingly the variables will get updated here. Okay. So you see that the class name over here has been updated. I'll just open that. So you see that these are the class names. So 0, 1, 2, 3, 4, and so on till 9. So as I was saying, we are trying to classify the digits, right? And digits can be from 0 to 9. So that's why from 0 to 9, there are 10 classes, 10 different classes that we can have. And we want to segregate whatever data that we are feeding it into the network into these 10 classes. So AlexNet had 1,000 classes because there were 1,000 different options over there, and that was trained for. Here it is just 10 because there can be only 10 digits. Okay, so that is what we did. The next part over here is, so we have a lot of data, right? So with that data, there can be first scenario can be you take all the data and then use it for training. Can someone tell me what might be the disadvantages of this? Or what will happen if you do something like this? You have a lot of data, you use all the data for training. That should be the case over here, right? We should be generally doing that, right? Use the data that we have and then train it. But what will happen because of that? What is the challenge that we might face? Any guesses are fine. Exactly, no data for testing. But we can test the same data that we had, right? So just for example, if we use if there are 100 data sets, we use that 100 data set for training, and maybe one or two or three, four data sets from the same 100 options we take and use for testing. What will happen in that case? Accurate results or inaccurate results is what you mean. Okay, so I'll again put.
So we may
Okay,
get the
so
false prediction if there are many.
inputs.
So do you mean that if we are using the same data for testing, we'll get a higher accuracy or lower accuracy?
Probability may be there if the training and testing is on the same one.
Okay, so I'll put it in other words. So what happens is it's like uh, uh, giving out answer key to a student before the examination, and then the student has the answer key also and the question paper also, and then he or she is going to write the exam. Now he or she may achieve good marks, but that does not guarantee that the student or is well versed with what is being taught or his knowledge is updated is not that we can be assured of, right? And the similar scenario happens over here because the data set that it is trained is being used for testing also. The data is already biased for it, and it is highly probable that it will give good accuracy, but it may not be that good of a network. And that's the problem that comes in over here. And that is why what we want to do is we want to hide some data from the network. We want to keep it aside, and this data we want to use it for testing so that it is a new data for the network so that it won't get biased onto that, and we'll get the accurate uh, prediction or understanding of the network whether it is working fine or it will work fine for the real data as well or not. Understood what I'm trying to do, what I'm trying to say over here. And that is the reason here what we are doing is we are segregating 70% of the images for training, 15% for validation, and 15% for testing. And again, how we are doing it is in a randomized fashion. So again, I don't want to bias the data like first 70% for this, 15% for that, and so on. I just want to randomize this distribution also. So this is again an inbuilt function which is helping me do that. IMDS is the data store where which I want to segregate into this way, and then I'm saving it into different variables. One is IMDS train, so that is the training data. This is the validation data, and this is the testing data. Okay, so just run through this section, and you will be able to see that corresponding variables are getting updated over here. Okay, the next part, what I'm trying to do is now I have the data ready. So even when you are talking about the workflow for deep learning, so the first and foremost is preparing the data that we are already done. And now the next part is to model our algorithm. So to do that, again, there are two ways to do it. One is through program, writing lines of codes and then executing it and creating a network. Other easier way is to do that using the apps. So that is the UI based way of doing it. So I'll do that first, and then I'll also talk about the programmatic way of doing it. One way is to just write this particular line of code and execute it. That will open the deep network designer. Other way to do that is go in the apps, click on this drop down, go to machine learning and deep learning options, and then click on deep network designer. Doing it this way or this way will open the same app. I'm just clicking on that app, and then a separate window for that app will open up. So what we are trying to do over here is we are just trying to open or create a network using the app. So meanwhile, this opens up any queries that you are having at this point. Please feel free to voice it over or even put it in the chat. Okay. So now this is the tab that opens up. Now, because we are opening wanting to create a network from scratch, I'll just click on this blank network. But for any other application, if you are using some pre-trained networks or anything, you can just open these networks accordingly. So we were talking about AlexNet and other things, so all you will find it over here. Sometimes the networks may not be downloaded over here. So this is not installed. So you'll get an option to install also if you're working on those particular networks. For this particular application and this particular demo, I'm just opening a blank one. So I click here. It will create a blank canvas for me. Okay, so now this is entirely blank. So I want to create it from scratch. So the first and foremost layer that I want to drag is having an input image layer because we are working on images and this is a two-dimensional image. So I'm just taking this particular layer, left click on that and dragging it onto the canvas. Now I have this layer on my canvas. Now for this particular demo, the images that I'm having, it's of a particular size. So I need to specify the input size accordingly. So here I'll specify it to be 28, 28, 1. Now this can be different for you. This can be different specific to the application. If it is a color image, this 1 will become 3. And this will correspond to the size of the input image that I'm feeding to the network, or I want the network to be of the size of. For AlexNet, we saw that this was 227 cross 227 cross 3. Here it is 28 cross 28 cross 1, and that is why I'm keeping it that way. Okay. So the next layer I want is convolutional 2D layer. So I drag it from here and leave it here. Next I want is a batch normalization layer. So I'll just search it in the layers. And sometimes if I know the name of the layer and I'm not able to find it, just try writing the name of it and it will show the layer. So I write 3 alphabets over there, I get it. I click and drag it here. Okay. The fourth one that I want is ReLU layer. Again, I can search it or I can just write the name of it. Okay, so I click left click and drag it down. Again, it might be a bit overwhelming at this time to like you might have questions like how do we get to know when to use a convolutional layer or a batch normalization layer or a ReLU layer or something like that. And I understand that it might be very preliminary stages for you to understand it right away, and that's why you can go back later on the documentation that I will be sharing and to understand it. But just for now, assume that you know these layers and then you are trying to create a network around it. Okay. So after this, we need a fully connected layer. Again, I just write fully and I get the option of that. I drag it here. For this particular fully connected layer is the place where we actually define the output size and all. So it is equal to the number of classes, and here the number of classes is 10 because we have digits from 0 to 9, and that is the reason I'm putting it. I'm keeping it as it is as tens because there are 10 classes. And then at the very end, I want to have a softmax layer. Softmax layer helps to convert uh, scores into probability. So that is what it will do here. And once I have that, I guess my network is ready. So what I'll do is I'll just connect these layers. So I just drag and drop and connect the corresponding outputs to inputs of the next layer and so on. And my network is ready now. So now this is the skeleton of the network. This does not have any information. This is not trained at this point. It is only the skeleton of the network. Okay. So just to understand whether I have done something, whether there are any errors or something, what I do is I just click on analyze here, just to analyze it as the name suggests. So it will check for any warnings or errors that the network might have. So if there are any errors, you can actually go to that particular layer and then uh, work on those particular errors or rectify them. Okay, so you see that there are no errors. So I assume that the network is fine. The next stage, next step, what we do is we actually export this network to our workspace. So you can click here, You can also, if you're working on Simulink, you can export it to Simulink as well. But right now we are just working on MATLAB, so I just want that network on my workspace, and that is the reason I click on export. So it will ask me what name I want to have this network. I'll just keep it as default, net_1, and click OK. So it is showing that the network is exported to workspace. Now let's go back to our MATLAB window and check whether on the workspace whether it is there. So you can see that there is net_1, and this is my network that is created. Again, I would say that this is of the type DL network, but it is of no use as of now. No use as in it is not trained at this point of time. It is just a skeleton of the type DL network. It does not have any information. Okay. So we have already gone through these steps. Now I was also mentioning that there is a way to create a network without using deep network designer, right? And that is programmatic way of doing it. And if you were to do that in that way, then these are the lines of code that you will be writing. So basically what you are doing is you are writing the name of the network and then mentioning explicitly and manually which layers you want to have. So it is the input layer, convolutional layer, ReLU layer, etc., etc. And then you're also specifying the sizes and what you want to do. So we change these particular things, and we actually, so we were doing that here, right? This bit, we already did that. Here we are doing it programmatically. So because we have already done that, I'm just skipping this particular part because we have done it using deep network design. So the next step is the next step is to have training options. Again, I would suggest so we are using some training options over here. Again, depending on the application, these might vary. So here we are using it using as 4 epochs, and we are keeping the learning rate as 0.01 only. Again, for your application, you might have to modify this, change, try out for different epochs or learning rate or other training options, and then come to a conclusion on what is the best combination of these training options. For now, I'm just using as it is and then running through this particular part. And then trainNet is an inbuilt function which will help me to train. So IMDS train was my training data set. Net_1 was my skeleton of the network, and then I'm also defining it to be a cross entropy. And these are the options, training options that I'm passing it over here. So this is the variable that got created for options, and that I'm passing it over here. So it will open a separate window for me once it starts training to show me how the training looks like. So it takes some time to just analyze and rework around it. But meanwhile, does anyone have any queries? So first and foremost, what we did is we tried to create a skeleton of the network. We tried to get in some layers and try to create a skeleton which looked like this. Then we had some changes around about some particular layers, some parameters of these particular layers. Once that was done, we exported it to the workspace. And then we set in some training options. And then those options were passed. Those options were passed to the network. Okay. Now you saw there is another window that popped up. So the training process has actually started over here. So it shows that how much time it has elapsed, how many epochs, which epoch it is going, how many iterations it has done, and so on. And the hardware resource. So for example, if your laptop has GPUs, then the entire process will be much more accelerated because it might be using GPUs, and that will happen automatically. MATLAB will detect any GPUs on your on your laptops or systems, and it will happen automatically. Uh, for my system, I don't have a GPU. That's why it is just showing single CPU, and that is the reason it will take slightly longer time than a laptop having GPUs. So it will actually plot on how the accuracy is increasing with every iteration and every epoch. And it will also tell you what is the validation loss with every iteration and all that. So you can see that the network is getting trained. So let's wait for a moment for the network to get trained so that we can go to till the next steps. But meanwhile, can you just let me know if you have any queries to the process and the steps that we followed right now?
Yes, participants, if you have any query, you can unmute yourself and ask the question.
So to just save on some time, what I'll do is I'll just stop this training. But for a good accuracy, it would be good if you let the entire training to complete. Here, what will happen is because I'm not having the entire training to be done, the network will not be as accurate as we expect through the entire training would have been done. Okay, so I go back to this MATLAB window. So assume that we have trained it completely. The next part is just test it. So what I'm doing is this particular part will just let me test the accuracy of the network with the training that I have already done. So you see that the accuracy is around 91%, but if you would have let it complete, the accuracy might be a bit higher also. And to test the accuracy, now we are using the data set named test over here, and we are not using the training data. So the training for training, we use IMDS train. Here we are using IMDS test, sorry. And that is how we are getting an accuracy of 9.91 over here. So again, homework for you is here we had options, right? Different training options. So you can try out different training options and see how the accuracy of the network, how the accuracy and the training time changes for the network. And then you will come to a conclusion on how which one is an uh, optimal training option for you. Okay. So you have this particular file and you can go over that. Again, this is a quick section where you now use the testing data to predict and have the prediction scores and other things. I'm skipping this part, but you can work on that at a later point of time as well. Okay, I'll quickly go back to my uh, slide. So what I want to show you next is in this particular example, what we did is we created the entire network from scratch, right? Uh, So this was the part that we did. We started all the layers that we wanted. We actually created it, modified the parameters, and then created the entire network. Uh, And then now what we want to do over here is assume that it is a complex algorithm that you want to work on. It's not always practically possible that you would build over every layer, right? So what we do is we just take some network which is already available and which is already trained, which is working fine, and then change some layers onto it, which would suit our application, and then use that network for our use case. So that is what we call as transfer learning. So we load a pre-trained network, we replace some final layers, and then train the entire network for our use case or our data set, and then use it for our specific application. So that's how it is. It's pretty straightforward. A pre-trained network is taken. So for example, you take AlexNet or something like that, change something around it at the final layers, then train it for your data set, and start using it. So the advantages that we get over here is, first of all, that because there is a huge amount of training that is already done, it is highly probable that it will work specifically for your application. Secondly, you don't spend a lot of time in looking at the coming up with an architecture for the entire network. You already have the architecture ready, so you take something off the shelf and create it more custom for your application and start using it. So for that, what we'll do is we won't be doing this particular exercise, but I have another exercise for you. We'll just close this. We'll go back to MATLAB, and then there is a ECG classification example that we'll do. So, and that is the reason why I mentioned this particularly is why we need to understand images in a better way before we get into signals. Is there are ways where signals can be represented as images, because sometimes it becomes difficult to work on signals directly, and that is the reason what we do is we convert signals into images, corresponding images, and then work on them. This is slightly taking more time than it should. But any queries till this point of time? So Ranjana ma'am has a question like, what is the benefit of preparing our own network compared to an existing one? So assume that you had an existing network of AlexNet, which is already trained for thousand of classes, right? Now you want to use AlexNet again for classification of images only, but your class size is lesser. Say you just want to segregate some animals into maybe dog, cat, and something else, or maybe just two classes that you want to have. So it can be dogs or cats. So your application is much more smaller than what the entire network is. So it is always better to change some of the classes for which will some of the layers which will suit your particular application, and then train it for only dogs and cats so that it is more robust and more accurate for your thing. So that's why we try to use transfer learning in such scenarios. So Professor Narkade, the IMDS error that you are getting is probably the previous lines of code you haven't run. So the data store part is not run. So that's the reason your IMDS data store is not created in the workspace as the first instance. So I would suggest you to run through the script from the beginning and not directly, or you might have missed some of the sections in bit. Okay. So again, this is for some reason this is taking longer. Okay, yeah. So what I'm doing is I'm getting into this particular option. Also, I just want to confirm if it is okay if we go about 10-15 minutes over the time. Okay. Yeah, not more than that. I would wrap up around 115 or so at the max. So what I want to go is I open the signal classification ECG folder, and then there are multiple files over here. So I'm working on the CNN one, convolutional neural network one, and not the LSTM one. So I'm opening solution underscore ECG underscore CNN. And I would suggest everyone to just observe for now. Files are anyway with you. It is good that you understand it first, and then maybe you can work on the files later on as well. So what we are trying to do is, again, ECG dataset is a signal dataset, right? And we are trying to use apply some classification algorithm. So again, there can be multiple ways of doing it. It can be CNN, it can be LSTMs. LSTM is basically a long short-term memory network. For this particular application, we are or this particular example, we are just using the CNN way of doing it. In tomorrow's and day after session, we will also look at other ways like LSTMs and all. Nikita might come in and show you one of the example around it. So what we are trying to do now is assume that you have ECG dataset and you have different classes around it. So ECG dataset for normal person, ECG dataset for an arrhythmia person, and ECG dataset for congestive heart failure uh, person. Okay, so these are three classes that we are talking about, and we have ECG data segregated into these classes. And I want to create a network, or I want to have a network which will help me classify these three data sets. So if something new, some new data set of ECG is given to this network, it should be able to classify whether it is normal or or arithmetic, or it has congestive heart failure. Okay, understood the problem statement over here? And here what we are trying to do is we'll use an existing network and we'll try to modify some of the layers onto it, which will and try to fit it for my particular application or this particular application. Okay. So here what I'm trying to do is, again, data is there in the folders already. So I'm just accessing that data and trying to plot one of each of the data sets. So one normal data, one arrhythmia sample, and one uh, CHF sample is what I'm trying to plot. So I'll just run through this particular section. So it will just help me just to understand how the data looks like. And I'm just using the first data set for everyone. So this is the NSR, normal sinus rhythm. This is arrhythmia, and this is CHS. So again, there are a lot more features that you can look into look into by naked eye and see that there are some abnormalities and there are some differences between these features or these particular ECGs. But I want a model to look into it and give me the solution. Okay. So first and foremost is pre-processing of data. And as I said, we are not going to directly use the signals because we are using a CNN. CNN, as I said, is a convolutional neural network, and CNNs are generally used for images. So to make the entire problem statement easier, instead of using signals, I want some representation of these signals into images, and so that my features are easily extractable and I can work on a CNN network easily. So to do that, what I do is, so we know that for every signal there is some kind of a time frequency representation, right? So what I do is for every ECG, I convert it to a continuous wavelet transform. So now my wavelet transform is my image, and these images are then inputs to my CNN or the network that I'm working on. So my network will only won't see the signals as it is. It will just see the wavelet transform that I'm feeding it into, and these will be images. Okay, understood why how I'm using this as a transform. So this is a part of data preparation and pre-processing of data before I feed the data directly into the network. I hope that is clear. So my signal is converted to the corresponding wavelet transform, and this wavelet transform image is being fed to the network, and that we'll be using for training. Now again, this is just for us to visualize. So I'm just taking in one of the data set just to visualize and just computing the continuous wavelet transform contact. It will look somewhat like this. Now, this is for CHF data that we have, and I'm just trying to have a scalogram of it, the CWT of that. Now, this is just for one. Now we want to have this operation done for all the signal data that I have, or for all the ECGs that I have. So again, there is a script that will help you to do that. So prepare signal data.mlx, it is already there in the folder. That script will help convert all ECG data to corresponding CWT data. Now, just to save some time, I have already done that, and I have saved all the CWT data, continuous wavelet transform data, over here. So this particular folder into wavelets, if I see, it has all corresponding folders of specific conditions, and then there are JPG images of that. So these are the CWT data that I already have and created and saved it into the same folder. So we don't need to convert the ECG data to CWT data and then go ahead. CWT data is already there. Okay, but you can, as a homework or as an exercise, you can run through this particular script and create the CWT data again. So again, as we have seen previously, I'm just trying to create a data store. And to create the data store, I'm specifying where exactly is my data. So that is in this folder. And then I'm just trying to visualize some of the data over here. So I'm just visualizing the arrhythmia data and maybe 1 to 4. So again, randomly, I'm taking 4 data sets from there just to visualize it. So these are the 4 data sets for arrhythmia that I'm going to visualize. You can change this to other conditions and visualize 4 data sets from others also. This is just to visualize and nothing to do with the training part as of now. Now again, the next step is to split the data into training and testing. So 80% of the data I'm splitting for training and the rest I'm keeping it for testing. Just the same way we did for the last example also. Okay. Now again, I want to open Deep Network Designer. So I go in the apps tab, same process that we followed for the previous one. Here now what we are trying to do is we won't be creating it from scratch, but we will be uh, using an existing network, an existing pre-trained network, and then modify it as per our requirement. Okay. So here previous one we started with the blank network. Here I want to take a pre-trained network, and here specifically I'm taking the SqueezeNet network. So I open this particular pre-trained network. So it will be loaded to my Deep Network Designer, and then we'll do some manipulations on that. So if you look over here, this is I'll just zoom into it. So this is the SqueezeNet network that we have. It's a very complex network. It has multiple layers, multiple junctions, and so on. So, and that is the reason we are using transfer learning, because it is a complex network. I want to use this complex network. If I were to use this from scratch, it would have been difficult, like creating something like this from scratch. So what I do is I'm just importing this pre-trained network and then changing some of the layers and then going ahead with it. So what I do is I'll zoom in a bit more. So the last learnable layer is the convolutional layer over here. So I want to change this layer. So what I do is I take a corresponding convolutional 2D layer, put it here, drag and drop it here, and then change it according to my requirements. So for my requirements, the filter size should be 1 cross 1. and the number of filters should be 3. Now, number of filters correspond to the number of classes that we have. SqueezeNet had 32 classes specifically, but for our application, it is arrhythmia, normal sinus rhythm, and congestive heart failure. So that's why it is just 3 classes, and that is the reason I'm keeping this number as 3. The learnable weight factor, again, I'm keeping it as 10. Again, this can be specific to your applications also. And bias learn rate is also kept as 10. Okay, these are the major changes that I do. And I delete this particular layer and then replace it with the net layer that I just created. Okay, so now my layer, the layer that we just created is in this particular layer. I then analyze this network just to check if there are any errors or something that we want to see. It will just check for any errors if there are. And once we are done with this, maybe we'll just export it the way we did in the previous step also. So we'll just export, click here. So there are no errors. So we are just exporting it to the workspace. I'm just changing the name of this to net_1 only. It will just override the previous network, and that is okay. And once that is done, we go back to check whether it is updated. So we have we should have net_1 somewhere here. Yeah, we have it here. So now what we are next we are trying to do is, again, these are some of the steps if we were not using the Deep Network Designer app, and what to do it programmatically is what we will do. We'll import the SqueezeNet using a inbuilt function and then change some parameters to it. Here we are directly using the network that we have. Okay, so these are the changes that we did. We already did it, and then we set in some network hyperparameters. We are setting these options specifically so that these can be used for training now. It's again the same thing, similar thing that we did for the previous example also. And then we start training using the trainnet option. So now here, differently what we did as compared to the previous example is, previous example we had all the layers created from scratch and then we trained it. Here we just took a pre-trained network, just modified 1 or 2 layers at the very end, and then again trained it for the data set that I have, or started the training for the data set that I have. Okay. And once the training starts, it will take some time to train and then we'll test it for the data set that I have. So here, the advantage that we got is we are able to use a complex network, which is working fine in such applications. And we can custom make it for our application. So we are able to use SqueezeNet architecture for uh, for an ECG example that we have. So SqueezeNet network is being used for ECG, whereas SqueezeNet is generally not specific to ECG, but we are making it custom made for ECG. I hope that is clear on why we are using a custom, or why we are using transfer learning over here and how it can be helpful. So the training will start and it will show how the training starts and the graph with this training accuracy and training loss. It will take some time, as I said, because my laptop has just the CPU and not GPUs. But what I mean, what I want you to understand is if you got the entire process that I'm talking about, uh, training and other parts, it will take time, and you can do it at your end also later on because you have the files. but I just want you to understand the process. And if you have any queries with respect to that, please let me know. So let it run at the back end. I'll just show you what next steps are. So once the network is trained, then probably we'll just test it out and we'll see the confusion matrix and other things like what is the probability of it giving out correct results versus the probability of it giving wrong results and so on. So that can be visualized using this part of the code, and you can run this once the training is done. Here it will take some time because the data set is larger. So probably, I guess there are some slides that I have skipped on how and when LSTMs can be used. If these slides are mostly self-explanatory, I can share the slides with you and have a look at it, how these are useful. So I would like to conclude today's session with this particular slide on how you can use MATLAB for such applications. So because it supports a lot of data inputs, a lot of data types, so it can be used from the data preparation stage to the deployment stages. So the entire workflow for the deep learning algorithm can be done just using the same platform, and it's currently being used like it has specialized tools for specifically for scientists and engineers who are working on different applications in AI as well. And if someone is working on other platforms, I have already discussed that it interoperates well with open source frameworks also. So it's not that you have to use MATLAB only. It can be a scenario where you have a network in PyTorch or TensorFlow and you use it for MATLAB. You like bring that network to MATLAB, use like have some kind of post processing applications like signal processing on MATLAB, and then again take it back to TensorFlow or PyTorch. So there you're using the best of both the worlds because MATLAB is more predominantly a stronger tool when it comes to applications like signal processing, and then you're using TensorFlow or PyTorch or any other OSs for deep learning applications. So you can use best of both the worlds to make your algorithms more robust and more easy to create and understand as well. So with that, I thank everyone. This is my mail ID. I know we are at the top of the hour and we may not have time for questions. I will leave that to the organizers if we have some time for questions. I am okay to wait for next 5-10 minutes also. Uh, if anyone needs to drop off, maybe you can just scan this particular QR code and put your questions or any other feedback that you have, and I'll be happy to get back to you on that. You can just mail me as well, and I'll be happy to connect as I mentioned. If you are also working on any of the courses or if you are planning to use MATLAB to teach with any of the courses, and you need any help from any of our team members, Ankit is also there in the call. You can just put that as a you can just put that in the form. There is an option or a question there, and we shall be happy to get back and discuss with you on a one-on-one basis. So if there are any questions, please feel free to unmute or put it in the chat as well.
We have a question in the chat
Yeah,
box.
yeah. So Ranjana ma'am is asking, existing network takes more time or own network takes more time for training or testing. Now, again, this is a very subjective question. It depends on how big is your network or how complex is your network and what network are you comparing with. For example, if a pre-trained network is much more smaller and has lesser layers, but your created network is much more complex, then your created network might take a longer time. And vice versa, if your pre-trained network is much more complex and the created network is uh, much more simpler, it will be the vice versa. So it's not right to compare like this. It is completely subjective. Uh, but if you are saying that it is the exact same network that you have, there is pre-trained and then you have created as well, the likelihood of that happening might be very less, because if you have it already as a pre-trained network, you won't try to create it from scratch. But in that scenario, hypothetically speaking, a pre-trained network might be quicker because it is already trained for some aspect of it. It already has some kind of activations onto it already. So that might be slightly quicker than doing everything from scratch. But again, there can are scenarios where you will have to go with everything from scratch. Yeah. Uh, I would again request everyone to scan this particular QR code and put your feedback and your queries in there. Even if you don't have any queries, please fill in the feedback form so that I have your contact details and I can reach out to you and share the resources and the slide decks with you. So if you fill it in, I'll have your mail IDs and I can just share the slide deck and the content which I have. Content anyway is there with you. I'll share the slide deck with you. And also in the content, there are some extra files also that I have shared. There are some transfer learning examples, extra transfer learning examples I have shared. You can try that also. That will help you to understand different flavors of it. There are some image files that I have shared, and the entire file is self-explanatory. So you can just go over that. And if you, again, even in that, if you have any queries, you can reach out to me or Ankit for any support. So Gayatri ma'am is asking if there are multiple classes which deep learning model can be used for classification. Again, it is very subjective and depends on the application that you have, because there are lots and lots of networks that are readily available. We used two of them today. One was AlexNet, other one was SqueezeNet. So again, it depends on what application you are working on and what you are trying to do. So all the examples that we looked today were classification examples only. So it is very subjective. It's very difficult to answer one network with the information that you have given me. But if you want to have a deeper discussion around this, please feel free to drop a mail, and I'll be happy to discuss this on one-on-one basis. I'll also write my mail ID in the chat so that you can directly copy it.
Screenshot.
Yeah, I pasted it in the chat also. You can just copy it and save if needed. And if you are working on any examples, we are working on any of the research in this particular topic, or plan to have any courses where you plan to use AI or MATLAB or anything where we need our support, please let us know and we'll be happy to get back to you and help you. So with that, I would like to close today's session and hand it over back to the organizers. Maybe thank you everyone for attending and patiently listening and understanding over the entire last 2.5 hours. It was great to like talk about this topic in much more detail. We have another 2 days of session coming up, so stay tuned for it. We'll get into more details of deep learning and specific applications related to signals and the overall biomedical landscape. So thank you everyone once again, and I would like to hand over back to Professor Amruta if there are any closing remarks.
Thank you, Nikhil sir. Thank you for such a knowledgeable, insightful, and engaging delivery. Today's session was very insightful. I guess the participants must have, those who have performed the hands-on session parallelly with us, must have got very much of knowledge regarding the deep learning models, how to implement it. On behalf of E&TC Department, Dr. D.Y. Patil Institute of Technology, Pimpri, Pune, I extend my heartfelt gratitude to Nikhil sir for giving us time today and delivering the session. Your topics were truly enlightening and it will be helpful for those who are working in the research domain, I guess, most probably related to the biomedical part. We appreciate your time and effort. Thank you.
Yeah. Thanks, everyone.
Thank you, dear participants. We conclude today's session.